Good morning, Year 6. Really well done to everyone who's been completing that algebra work so far. I've been really impressed with the standard of work and the quality and neatness that you have been achieving. Really good job. Just going to share my screen with you so that you're able to see today's learning. The first thing I'd like to say is you need to make sure that you've got a pencil, some paper and a coloured pen or highlighter for marking. The vast majority of you are marking your work as you go along and marking your work at the end. I'm showing you an example here of someone who's completed their work carefully, and then at the end of the video they've stayed on to listen to the answers and mark them carefully down the side. This means that they know exactly which questions they got right and they can ask for help with any questions they struggled with. It's also important to note that as I'm going through the answers, for the harder questions I will spend more time on them and show you exactly how you could have solved them. So it's really advised that you mark your own work by carefully watching the video and checking your work against what's there. Okay. Can you please pause the video now and have a go at completing these 6 morning arithmetic questions? Brilliant. You should have finished your morning arithmetic questions. I'm going to go through the answers now with you. For some of these, I've just written the answers in because it's important to get onto the main learning. Remember, there are loads of different ways of solving the short division, which is why I'm not going to go through it with you now, but your answer should be 92. For question 2 with the fractions, you need to convert 5 2/4 into a mixed number, 23/4, and then 1.5 we make 3/2. Then you need to make sure that 3/2 is expressed as quarters, making it 6/4. Adding them together will be 29/4. If you wanted to, you could have also expressed that as a mixed number. You could have done 29 divided by 4. I know that there are going to be 7 groups of 4 in 29 and 1 left over, so it'd be 7 1/4. For your long multiplication, you should have got 82,537. For question 4, you could have done it as finding 4/5 of 150, or you could have done 4/5 times 150. Myself, I would have done 4/5 of because it would be quicker to complete in my head. 150 divided by 5 is 30, and then 30 multiplied by 4 is 120. 1 7/8 needs to be converted into a top-heavy fraction. 1 times 7 is 8, add 7 is 15. Then I'm subtracting 3/7 from that. Because now I have 2 different denominators, I need to convert them again so that they have the same denominator. I need to multiply 8 by 7 to get to 56, and 15 times 7 is 105. 7 needs to be multiplied by 8 to get to 56, and 3 times 8 is 24. Then I'm doing 105 subtract 24, which will give me 81/56. Finally, for question 6, you could have done that in your head knowing you had 8 wholes and you've chipped away at one of them, leaving you with 7 wholes, and the remaining fraction will be 5/7. Or you could have converted 8 into a fraction over 9, which would have given you 81/9. Sorry, 72/9. 9 times 8 is 72. 72 subtract 4 is equal to 68/9. Both are correct answers. Please pause the video now and have a go at these questions for your reasoning. They're quite difficult, especially this one here. So my advice to you for this one is to make sure you're converting when you need to. Okay, going through the answers for these ones then. For some of them, I've just written the answer for you. For this first one, the digit in the tens place is 1, the value of the underlying digit is 400,000, and rounded to the nearest million is 28 million. Let's have a look over here then. I advised you to convert this first fraction. If you convert it into sixths, you will have 1 and 4/6. Now I can work out what's being added each time. Each time I seem to be adding 3/6. That means here I need to do 1 4/6 add 3/6. That will give me 2 and 1/6. Then I add another 3/6 to get 2 and 4/6. Now I'm going to add 3/6 again, and I will have 3 and 1/6. If I'm subtracting 3/6 from 1 and 1/6, I will be left with 4/6. For this question here, you needed to work out what you're adding each time. The difference between 84 and 113 is 29. So if I add 29 to this number, 113, I will get 142. I add another 29 and I will have 171. If each time from left to right I'm adding 29, to go backwards I need to do the inverse, which is subtract 29. 84 subtract 29 is equal to 55. For this next question, before I can compare them, I must convert them to have the same denominator. I'm going to start by converting 3/5 into 20ths because I can see that all of the denominators in the first question can be converted to 20ths. To get from 5th to 20th, I need to times by 4. That means as 20ths, I've got 12 over 20. Now I'm going to go through each of these numbers and make sure they're also in 20ths. This first is already in 20ths, 12 over 20. 12 over 20 is not greater than 12 over 20, it's the same. 1 over 2 as 20ths would be equal to 10 over 20. That is also not greater than 12 20ths. To get from 10 to 20, I'm multiplying by 2, so 7 times 2 is 14. 14 over 20 is greater, so I should have circled this one. Finally, to get from 4 to 20, I must multiply by 5. 3 times 5 is 15, therefore this fraction is also greater than 3/5. For this one here, the second one, you can see that I've already got 20ths, so I'm going to just convert the ones that aren't in 20ths. I'm looking for a fraction which is less than 15 over 20. To get from 4 to 20, I times by 5. 3 times 5 is 15. 15 20ths is not less than 15 20ths, it's the same. 16 20ths is already converted for me, so I can see it's clearly not greater than 15. To get from 5 to 20, I times by 4. 3 times 4 is equal to 12. 12 20ths is less than 15 over 20. Finally, to get from 4 to 20, I times by 5. 2 times 5 is 10. Therefore, this one is also less than 15 over 20. You could have also done that one by spotting that 2/4 is exactly 1/2. Okay, finally, John thinks of a number. Because I know it started with thinks of a number, I draw my question mark and write out my equation. He adds 19 and then he doubles his answer. That's the same as timesing by 2. His final answer is 100. I'm now going to do the inverse of this in order to find what he started with. 100, instead of multiplying by 2, I need to divide by 2. 100 divided by 2 is equal to 50. Okay, now for the second step, instead of adding 19, I need to subtract 19. 50 subtract 19. I'll start by taking away 10, which gives me 40, and now I'll take away 9 to leave me with 31. Let's just double check that works the other way around. I think of a number, 31, and I add 19. 31 add 19 will be equal to 50. Then you double that, double 50 is equal to 100. Well done. I'm going to ask you to pause your video again, and this time you're going to write the date and WALT on your piece of paper. Once you've done that, I want you to have a go at the do now, which is practicing the skills we learnt yesterday. If A is equal to 2 and B is equal to 10, what would the answer to these equations be? I'm just going to change that slightly. There we go. Pause the video now and have a moment to solve these ones. Sorry. Okay, so 3A. If A is 2, that's 3 times 2, that's equal to 6. 4B. If B is 10, that's 4 times 10, which is equal to 40. A plus 19. If A is 2, that's 2 plus 19, which is equal to 21. A plus B, that's 2 plus 10, which is equal to 12. AB. This was a trickier one from yesterday. Remember, with algebra, AB is a shortened version of A times B. So that means I'm doing 2 times 10, which is equal to 20. Then finally this two-step one here. 2B, I shall solve first. 2 times 10 is 20, and then take away A. Remembering A is 2, so that's 20 subtract 2, which is equal to 18. Make sure you mark those questions as we're going along so you know what you're finding challenging. Today, our learning is going to heavily involve your knowledge and understanding of the inverse. So before we go any further, it's essential that you understand the inverse of adding is subtracting and the inverse of multiplying is dividing, and vice versa. Okay, today we're going to be finding the value of algebraic expressions. I'm going to show you a first couple of examples and then you're going to have a go. My first one, I have 2A is equal to 4. When you're trying to find the value of A, that means you need to have it so that you've got A isolated by itself as the subject of the equation. 2A is equal to 4. In order to get A by itself, I need to get rid of the 2. The 2 there represents 2 times A. So to get rid of timesing by 2, I'll do the inverse, which is dividing by 2. If I divide that by 2, it cancels out times 2 and I'm left just with A. But if I've divided the left by 2, I must divide the right-hand side by 2 as well. That means I'm doing 4 divided by 2, which is equal to 2. A is 2. Let's check that makes sense. 2 groups of 2, yes, that's equal to 4. It might sound a bit confusing at first, but as we do more examples, it will start to make more sense. For this second equation, I want to find B as the subject of my equation. I need to isolate it by itself. But at the moment, I don't have B, I have 4 times B. To cancel out that 4 times B, I need to do the inverse of timesing by 4, which is dividing by 4. When I divide the right-hand side by 4, I'm left just with B. But now I need to divide the left-hand side by 4 as well. 16 divided by 4 is equal to 4. That tells me that 4 is equal to B, and B is 4. It's a little bit like when you're finding equivalent fractions. Whatever you do to the top, you have to do to the bottom. When it comes to algebra, whatever you do to the left, you have to do to the right. In this equation, I have 8c is equal to 24. I need C by itself. I need to get rid of times 8, and to get rid of timesing by 8, I must divide by 8. If I've divided the left-hand side by 8, I must now divide the right-hand side by 8. 24 divided by 8 is equal to 3. Let's check that makes sense. 8 times 3 is equal to 24. Yes, that's correct. Pause the video now and have a go at solving these equations so that you have isolated A and B as the subject of the equation. What's the value of A and what's the value of B? To get A by itself, you need to divide by 3 to cancel out that timesing by 3. 15 divided by 3 is going to be equal to 5. To get B by itself, you have to divide by 2 to cancel out timesing by 2. Now I need to divide the other side by 2. 12 divided by 2 is equal to 6. Well done if you got those two. We're now going to look at what happens if you've got adding and subtracting. It's exactly the same principle. I need to isolate A as the subject of the equation. I want it just to say A is equal to. That means I need to get rid of plus 4. You're right, I need to do the inverse to get rid of plus 4, and the inverse of adding 4 is taking away 4. That means on the other side, I need to also subtract 4. Can you see how in each of these equations, we're simply doing the inverse to isolate the algebraic expression by itself? The opposite of adding 4 is subtracting 4, so 10 minus 4 is equal to 6. In this example, I want to get B by itself. That means I need to get rid of take away 7. To get rid of take away 7, I do the opposite, which is adding 7. On the other side, then I'll need to add 7. 2 add 7 is equal to 9. My final example is down here. I need D by itself. To get D by itself, I need to get rid of take away 8. I need to get rid of add 8. I'll do that by doing the inverse subtract 8. 100 subtract 8 is equal to 92. Have a go at these equations by doing the inverse or the opposite in order to find the subject of the equation. Good. The opposite of adding 2 is subtracting 2, so we're doing 10 subtract 2, which is 8. Down here, the opposite of subtracting 4 is going to be add 4. So we're doing 10 plus 4, which is 14. And here, the opposite of add 40 is going to be subtract 40. 100 subtract 40 is equal to 60. Well done to all of you who got those ones correct. If you found that a bit tricky, I want you just to go back to the previous page and rewatch the video and have another go at it. The next set of equations look a bit more complicated than they are. You've just got to remember to yourself when it's expressed as a fraction, that's a shortened form of divided by. C over 4 just means C divided by 4. If you want to, you can write out the longer form to help you there. Because now it's exactly as before, I need to get C by itself. To get C by itself, I need to get rid of divide by 4. And the opposite of dividing by 4 is timesing by 4. Therefore, on the other side, I must times my answer by 4. 10 times 4 is equal to 40. Let's just check that makes sense. If C was 40, is 40 divided by 4 equal to 10? Yes. Let's look at this one then. Remember, you can write it out in the longer version if it helps you. F divided by 5 is equal to 12. In order to get F by itself, I need to cancel out by doing the inverse. The opposite of dividing by 5 is multiplying by 5. So on the other side, I will need to times by 5. 12 times 5 is equal to 60. Pause the video now and have a go at these questions here. In this equation then, I needed to times by 6 in order to get q by itself, and 3 times 6 is equal to 18. In this equation, I needed to times by 12 in order to get y by itself, and 12 times 12 is 144. Excellent work. We're just going to look at these examples very quickly, and then it'll be your turn to try some independent work. The final thing that you need to know is when you're doing a squared number. C squared is equal to 25. That means I need to find the number which is squared to make 25. I know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. That tells me then I've done 5 times 5 to get 25. I would keep going through my squared numbers until I got to the right one in order to find these. This is why your knowledge of the times tables is absolutely essential. Quickly think to yourself, what times what makes 64 and what times what makes 100? Well done. 8 times 8 is 64 and 10 times 10 is 100. It's now time for you to have a go at the first 12 questions on your worksheet. I'd like you to pause the video and have a go at answering these 12 questions. You can answer them from the video, or you can look at the independent worksheet because it's exactly the same questions. But don't go beyond the first 12 questions. Pause the video and try the first 12 questions. Please do not continue watching the video until you've completed the first 12 questions from the sheet. It's really important that you have a go at trying that work for yourself before we go through the answers together. Okay, I've got the answers for the first 12 questions written out for you here. Please pause the video and mark your work. In the next group of questions, we're going to be looking at questions where there might be 2 steps involved. And at this point then, it's essential to talk to you about the order of operations. We know that usually in an equation we would follow BIDMAS, brackets, then indices, then division and multiplication, and addition and subtraction. But actually, when we're using the inverse, we also need to do the operations in the opposite order. That means instead of following BIDMAS, we need to try and follow SUMDIV. Starting with subtraction and addition, then moving on to multiplication and division, then indices, then brackets. For the remainder of this video, I'm going to have BIDMAS written up here just so that you can double check you're following it from the bottom up to the top. Let's have a look at what I'm talking about then. In this equation, I've got 3b plus 1 is equal to 7. The reason I need to use BIDMAS is because you can see that this here means I've got a multiplication and an addition. Okay, so as I said, instead of using BIDMAS, I'm going to start from the bottom and work my way up. I don't have any subtraction, but I do have addition. So first, I need to get rid of my addition and subtraction. In order to get rid of plus 1, I need to do the opposite, which is subtract 1 from both sides. That leaves me, sorry about that, that leaves me on the left-hand side with 3b. Once I get rid of plus 1, I've still got 3 groups of b. I can't get rid of that 3 at the same time. I do it 1 step at a time. If I subtract 1 from the other side, then I'm saying 3b is equal to 6. Now my next step will be to get b by itself. The opposite of timesing by 3 is dividing by 3. So to get rid of that 3, I divide by 3. Therefore, on this side, I divide by 3. 6 divided by 3 is equal to 2. Let's double check using substitution that we learned yesterday that that's correct. 3 times 2 is 6, add 1 is equal to 7. Yes, b is equal to 2. Let's have a look at this one then. First, we have to do our addition and our subtraction. If I want to get rid of subtract 2, I need to do the inverse, which is add 2. That means on the left-hand side, I'm left with just 4c, and on the right-hand side, I'm left with 6 add 2, which is equal to 8. Now, in order to get c by itself, I need to get rid of times 4. That means I'm going to divide by 4. So now I'm going to do 8 divided by 4. That tells me that c is equal to 2. I'm just going to double check using substitution that's correct. 4 times c, which is 2. 4 times 2 is 8. Take away 2 is equal to 6. Yes, c is equal to 2. Let's look here then. First, I need to get rid of the addition and subtraction. The inverse of subtract 1 is add 1. So I'm left with 3f on this side now that I've got rid of subtract 1. And on the other side, I need to add 1. 11 add 1 is equal to 12. Now, I haven't finished yet. I need to get f isolated by itself. The opposite of timesing by 3 is dividing by 3. So I need to now do 12 divided by 3, which is equal to 4. Let's double check if that's correct. 11 is the same as 3f, that's 3 times 4, which is 12, minus 1. Yep, 12 minus 1 is equal to 11. I'd like you to pause the video now and have a go at this question by yourself. Okay, you needed to start by getting rid of your addition and subtraction. To get rid of add 1, you minus 1. That means I'm left with 2t on the left-hand side, and on the right-hand side, I'm left with 8. Now, you need to get rid of the multiplication. 2t is 2 times t, so to get 2 out of the equation, I need to divide by 2, leaving me with t on the left and 8 divided by 2 on the right, which is equal to 4. Well done if you got that one. Have another go at this one. Remember to start with your addition or subtraction. I need to get rid of add 2. In order to get rid of add 2, I'm going to subtract 2 from each side, leaving me with 3s on the left-hand side and 15 on the right-hand side. Now I need to get rid of times by 3. That leaves me with s on the left-hand side and 15 divided by 3, which is 5 on the right-hand side. Let's double check that works. 3 times 5 is 15, add 2 is equal to 17. Yep, s is equal to 5. I'm now going to show you some really challenging ones that use even more of the functions of BIDMAS. Don't worry if these ones seem a bit tricky to you. They are included just as an extra challenge for some people to really push themselves. Okay, so if I'm using SUMDIB, I need to leave my brackets until the end. First, I get rid of my subtraction and addition. I need to get rid of this subtract 3 by adding 3 to both sides. If I add 3 to both sides, on the left-hand side, I'll have 2c plus 1. And on the right-hand side, I'll have 9. Okay, what's next? I solve my, well, I've just got brackets left, so I need to go to my brackets. Inside of my brackets, I've got addition. So inside of my brackets, I will get rid of the addition first. To get rid of add 1, I minus 1 from both sides. That tells me that 2c is equal to 9 minus 1, which is 8. Now my final step is to get rid of the multiplication from inside of the brackets. 2c means I've times by 2, so I need to divide by 2. 8 divided by 2 is equal to 4. Let's have a look at one more like that. First, I need to start with addition and subtraction. To get rid of add 4, I will subtract 4. C squared then is what I'm left with on the left-hand side, and 20 subtract 4 is 16 on the right-hand side. Now I need to find what squared makes 16. I think to myself through my squared numbers, and I know that 4 times 4 makes 16. Let's check that with substitution. 4 squared, that's 16. Add 4, that's 20. Well done. Okay, I'd like you to pause the video in a moment and have a go at the following questions then. You'll see from question 13 to 19, it's 2-step problems. These are just like the ones we did in the majority of the second part of the video. Questions 20 to 22, I've included a couple of extra steps just to challenge those of you who are really excelling at algebra. Have a go at those questions, even if you find them tricky, and I'll go through them at the end. Once you've done that, I'd like you to have a go at these reasoning questions. I'm not really going to explain them because part of reasoning is being able to work out what to do from the question itself. Don't forget, at the end of the video, I'll go through the answers so that you can mark your work, and I'll also go through those trickier questions with you. Please do not continue watching the video until you've completed all of the questions from the sheet. In a moment, I'm going to go through the answers, but please make sure you've finished your independent work first. Okay, so for the first set of questions, questions 13 to 19, I'm just going to give you your answers there. Question 16 ended up being a bit tricky because you had to find a decimal. 5b subtract 4 is 24. That means you had to do 5b is equal to 28. You ended up doing 28 divided by 5. Well done to those of you who didn't get deterred and continued with your bust-up method to do 28 divided by 5. If you did 28 divided by 5 correctly, you should have got 5.6. We're now going to look at those harder questions that had more than one step. Let's look first at 6 is equal to b divided by 8 plus 1. I need to first get rid of my addition and subtraction. I'm going to subtract 1 from either side of my equation. That means I've got 5 is equal to b divided by 8. Now I need to get rid of divided by 8. In order to get rid of divide by 8, I'll times by 8. That means 5 times 8 is 40, and 40 is equal to b. Brilliant. In the next equation, then I need to get rid of subtract 4 first. I get rid of subtract 4 by adding 4. That tells me that b squared is equal to 16, and as we know from earlier, the square root of 16 is equal to 4. Therefore, b equals 4. And finally, on this one, I need to get rid of minus 6 by adding 6. 18 add 6 will be 24. That means that 4b is equal to 24. In order to get b by itself, I need to divide by 4. 24 divided by 4 is equal to 6. Really well done to everyone who was following the lesson today. I'm really impressed with your work so far, but please do make sure you're writing in the comments about the things that you're finding challenging during these videos. I'm really impressed with everyone who's been marking their own work, so please do make sure you're doing that as well, because it's really helpful for the teachers to be able to see really quickly what you were able to do and what you found challenging. I'll see you on Monday. Bye.